This video is going to help us understand. This video will help us understand a helpful but often forgotten technique that you can use when dealing with velocity versus time graphs to determine distance. If we kind of look at this, we have a couple different things going on. We are increasing our velocity, then we're going into constant velocity, then we're going to decrease our velocity. And that would be tough to do with motion equations. We'd have to do three different steps, or the Suvat equations would require 3 different steps. What we're going to use is the graph to kind of help us understand what's going on here. There are 3 different intervals. We had kind of do 3 different things. Now, if we look at this from a dimensional analysis standpoint, this is in meters per second, and this is in meters. If we would take the area, in general, area is something that's going to equal something's like length times its width. So if we would think maybe just about this square in the middle, that would be how many meters per second in terms of the units on the y-axis versus, or I'm sorry, not versus, but times the seconds. Seconds cancel off. What we're left with is meters. That's distance. So in this case, we can find out the distance traveled by finding the area under each of these different graphs. So the first one we're going to do is this one right here. This kind of green shaded area. That's a triangle. So the area for that, we'll call that A1, is going to equal 1/2 base times height. So 1/2 5 times 1 is going to equal 2.5 meters traveled. And the second part is just simply this red triangle. So we'll shade that in with red a little bit. Then we'll call that A2. That's going to be your base times your height. Your base is 2 seconds. Don't think it's 3. It's basically 3 minus 1, or 2 seconds, times your height, which is going to be 5 meters per second, which is going to give us a total of 10 meters. A3, which will be this blue triangle over here, is again 1/2 base times height. And you can tell this time we have a 2 second. So we're going to have 1/2 times 5 times 2. Well, these two really just cancel each other off. And we end up going 5 meters. So the total distance we travel, total S, is going to be 2.5 plus 10 plus 5, which is equal to 17.5 meters. Again, much easier than going through 3 equations and 3 different scenarios where we have to reset our conditions, because we start off with one type of acceleration, then no acceleration, then another acceleration, and it would be a lot more calculations, where this is really a pretty simple process to follow. This one's a little tougher because we only have 2 triangles, but this time we cross that x-axis. And that x-axis has some significance because we went from having a positive velocity to having a negative velocity. So we have 2 different types of areas going on. So again, right here we're going to go fill this in. We'll call that A1. So A1 is just going to be simply 1/2 base times height. 1/2, my base is going to be 2 seconds. I'm going to be responsible, write my units in here. And my height is going to be 5 meters per second. So this is going to give me 1/2 times 2 cancels off, and just 5 meters. Okay. If I switch to a different color, my green triangle, which would be this one down here, call that A2. A2 is equal to 1/2 base times height again. Oops, that's an H. Let me try that over so it doesn't look so messy. A is equal to 1/2 base times height. 1/2 the base, 2 seconds again, and -5. So what happens here? Well, again, this part kind of cancels itself out, and you get -5 meters is equal to A2. Okay? The important thing is we recognize there was a negative. So the total distance is going to be 5 plus -5, which is equal to 0 meters. And what we're trying to show is that you have a positive value for your area, it's positive distance. A negative value for your area means you had a negative distance that you covered. You have to combine those in keeping your negative signs. Turns out here we just ended up back where we started.